Alright, for 5.5 we're going to go through different properties of quadrilaterals, so different four-sided polygons. First you have the trapezoid. Trapezoid will have two sides that are parallel, and these two sides will always be the bases. So it could be turned on its side, but whatever the parallel sides are, so we can go ahead and mark these are parallel sides, those are your bases. So we could call this base 1, and this one down here is base 2. So for trapezoids, you have two parallel sides, and those parallel sides are the bases. Alright, for a parallelogram, you have opposite sides are parallel. That's how it gets its name. So these top and bottom ones are parallel to each other, and then the right and left ones, I'm going to put 2 marks, are parallel to each other. So parallel lines. Opposite sides are also congruent. So we can mark, let's say I'm going to put 2 on this one. Those sides are congruent to each other, and then these sides are congruent to each other. You also have opposite angles that are congruent. So this angle on the bottom left will be congruent to the angle on the top right. Those are opposite from each other. And then the other two are congruent to each other. And then the last thing we're going to say is we have consecutive angles . Can't even read what that says. Consecutive angles are supplementary. So what consecutive angles means is they're basically right in a row, so consecutive. So this top left is supplementary with the one next to it. Those will equal 180 degrees, and it's supplementary to the one next to it on the other side. Those are consecutive. I can't skip an angle and go to the next one, so consecutive angles are supplementary. Alright, so we have trapezoids. You also have something called an isosceles trapezoid. So an isosceles trapezoid will have the bases parallel to each other, just like a regular trapezoid. So this is a base, and this is a base. And you also are going to have two side legs, leg and leg. So those legs are congruent. So I'm going to go ahead and mark those as congruent. The bases are not congruent, but the legs are congruent. And then we have some angle things happening. The upper base angles are congruent. So those are going to be this upper base angle and that upper base angle. Those are congruent. The lower base angles are congruent. So I'm going to give this one 2 curves as congruent. So those lower base angles are congruent. And then your lower angle that says lower even though you can't read it. Lower angle and upper angle are supplementary. So that's telling us that one of this upper base angle and this lower base angle will be supplementary and add up to 180 degrees every time. So for example, we could throw in some angle measures. Let's say this is 140 degrees. That means this is 140 degrees because those are congruent. And then because these are supplementary to each other, that means that that's 40 degrees and the other base angle is 40 degrees. Alright, moving on to our rectangle. Now a rectangle is a parallelogram. So that means that it follows all the parallelogram properties, which means you've got opposite sides are parallel, So that's going to be true. You also have opposite sides congruent for a rectangle. And then what makes a rectangle different from a parallelogram are the angles. The angle measures, so all angles are right angles. I'm sure you already knew that, but it's nice to put it in here. So that means that we're going to have these 90 degrees in each corner of your rectangle. And then also following the parallelogram properties is that your, oh no, not, just kidding. This is not true for parallelograms. So your diagonals, you can see the diagonals are drawn in there. That's going to be, a diagonal goes from one vertex across to the other vertex. These diagonals in a rectangle are congruent. So this line is congruent to this line. So from one all the way to the other, you have congruent diagonals in a rectangle. Alright, so properties of a square. A square is a rectangle, so it follows all of your rectangle properties, which means it's a parallelogram also. So we've got parallel sides. So let's start marking this up. Opposite sides are parallel. You have opposite sides congruent, although in a square, what makes a square different than a rectangle is all four sides are the same length. So we're going to write all sides congruent. But following the rectangle properties, you've got 90-degree angles. And you also have congruent diagonals. So these diagonals are congruent, just like they are in your rectangles. Alright, so a rhombus is a parallelogram, and it follows all of our parallelogram properties. So we've got opposite sides are parallel, and let's see what else. Opposite angles will be congruent, just like in a parallelogram. And then you also are going to have, this is different than a parallelogram, all four sides are the same length. So it's kind of like a square that you've tilted. So all sides are congruent. And your diagonals are not congruent to each other. However, the diagonals do meet at 90-degree angles in a rhombus. Alright, so last one is our kite. Let's look at this kite. So our two, we're going to call them disjoint sides, side pairs, are congruent. So what we're talking about is this side and this side are congruent, and also this side and this side are congruent. One pair of opposite angles are congruent. So that pair of opposite angles is going to be, this angle is congruent to this angle. The diagonals are perpendicular, so we're going to have right angles formed right here. And then one diagonal bisects the other. So you have two diagonals. You've got this one, and one of them is bisecting the other one. So which one looks like it's been cut in half? This one that's going up and down in this case. So that means that this side, I'm going to give it 3 marks, is congruent to this side. And those are your properties for a kite.